Welcome to all. So this is Selkumar from SNS Cloud Technology and Department of Computer Engineering. So now tell about CPU scheduling algorithm. So CPU scheduling algorithm, we have there are many CPU scheduling algorithm for deciding which of process in the ready queue and to be allocated to the CPU. So first one types, so first come first serve scheduling and the shortest of short scheduling and the priority scheduling and round robin scheduling. So first come first serve scheduling, so it is the simplest CPU scheduling algorithm. So in this, the process that requires the CPU first is allocated to the CPU first. So the implementation of first come first easily managed with the FIFO queue. The FIFO queue, so first in first out queue. So we have two different queue, N queue and D queue. So D queue is left side and N queue is right side. So we have a front or head side and the back or tail or rear head. So the process enters the ready queue onto the tail of the queue, and when the CPU is free, the process at the head of the queue will be allocated. So consider the following set of process in the time will P1, P2, P3. So 24 burst time is 24:33. So we have to draw the Gantt chart and the first turnaround time and fast waiting time. So Gantt chart means it is the bar chart that illustrates the process schedules, including the start and the finish time of each participating process. And the waiting time is the sum of time period. So open waiting in the ready queue. And the turnaround time is then sum of periods spent waiting to get into memory, waiting in the ready queue, and the execution of the CPU and doing the input output process. So first come first rolling Gantt chart. So for Gantt chart, first come in the first for 0 initial time 0. So it will take a 24 time to complete the process 1. So next one 3 time to complete P2. So 24 plus 24 plus 3 27. So P3 is completing next to 3. So it will take 3 more subjective. So P3 is a 27 plus 3 30. So this is the average waiting time and the turnaround time. So waiting time 0, 24, 27 and 24, 27, 30. So average waiting time 17 and turnaround time is 27 for first come first served. So average waiting time calculated the waiting time of P1, the waiting time of P2 plus waiting time of P3 divided by 3. So average turnaround time is turnaround time P1 plus turnaround time P2 plus turnaround time P3 divided by 3. Okay. So first comes in process scheduling. So suppose the process arrives in the order of P1, P2, P3. The Gantt chart for the schedule is, so waiting time P1 is 0, P2 24, P3 27. So average waiting time வந்து 0, 24, 27. Okay. Conway effect is short process began long process. So waiting time formula. So waiting time equal to start timing minus arrival time. So turnaround time equal to waiting time plus burst time. So this is the first come first served scheduling for considering another example of first come first scheduling for considering 5 process. So this is the example for that one. So next one starters job first scheduling. So these algorithm associated with each process that length of it is next CPU burst. Use these lengths to schedule the process with the shortest time. SJP is optimal, so gives minimum average waiting times for given set of a process. So this the difficulty is knowing the length of the next CPU request. So we have 4 different process and different 4 burst time. So SJS scheduling job B4 is a shortest job, so that is firstly will be executed. So next one is P1 and the third one is P3 and the fourth one is P2. So order is P4, P1, P3, P4. So average waiting time is 3 plus 16 plus 9 plus 0 divided by 4 plus 7. Average turnaround time, so we have to find out the considers. So preventing shortest job polling. So primitive version called shortest remaining time first. So we have 3 different categories: process, arrival time, burst time. So we have to consider arrival time. So we have different four process: P1, P2, P3, P4, P5. So we first one P1 is a 0 arrival time, and then next one is a P2, and the third one is a P4, and the fourth one is a P2. So average waiting time is a 10 plus 10 minus 1 plus 1 minus 1 equal to 26.5 million second. Prior to scheduling, priority number integer is associated with each process. The CPU is allocated to the process with the highest priority. So smallest integer equal to highest priority. So types primitive, non-primitive. So SJP is priority scheduling, where priority is the inverse of predicted next CPU burst time. So problem equal to starvation and solution starvation. The starvation created. Starvation means low priority process may never execute. And the solution process is equal to aging. So aging is a time progress increase the priority of the process. So non-preemptive, we had 5 different process: P1, P2, P3, P4, P5, and burst time 10, 1, 2, 3, 2, 1, 5, and priority 3, 1, 4, 5, 2. So priority scheduling Gantt chart. First one is a P2, so it's starting at 0. So burst time is 1. Next one is a P5 because the priority is 2. So 1 plus 5 6. So third priority is a P1 because priority is 3. The 10 6 plus 10 16. So next priority is P3. So priority is 16 plus 2 18. So last one is a P4. The period is 5. So P1 is 19. So average waiting time equal to 8.2 second. So primitive, in a primitive we have four different processes with arrival time, burst time, priority with different kind of we have to consider that priority as well as the arrival time. That is the preemptive scheduling. So in the round robin scheduling, so it is similar to first come first scheduling, so but preemption is added to the enable switch between process. So a small unit of time called time quantum, so time slice is defined. So after the execution time quantum period, the running process will be placed to at back of the ready queue and allows next process to occupy the CPU. So this is all about the CPU scheduling algorithm. Thank you.